Hello, my name is Keshwani. There's Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 262. Please turn to it. Page number 262, and today is our lesson number 373. On page 262, we see there problem number 14. They give us a rectangular box, and they're asking for two things. They're looking for the surface area, and they're looking for the length of the diagonal that they show us. Let's take a look at it. Let me reproduce the picture here as best as I can. It's going to the left, not to the right. All right. It's going to the left. Something like this, and the diagonal that they're talking about. Well, let's not worry about the diagonal right now. Let's first take care of the surface area. The dimensions that we are given here are 2, 7, and 10. This is 2, 7, and 10, and we are looking for the surface area of this solid. Now, what does surface area actually mean? So surface area means exactly what it says. Surface area means exactly what it says, which means it means the area on the surface. Area on the surface. And each of these parts that you see here, there's a top here, top of the box, there's the bottom of the box, there's a side here, left hand side, right hand side, there's a front, and there's a back. Each of those parts are called faces. It has 6 faces. Let's find the area of the top face and the bottom face first. Area of the top face and the bottom face. Area of top and bottom face. Bottom faces. The top face is this is the top face right here. This is 10, and this is 7, and this is 10. This side is 10, and this side is 7. So it's 7 times 10 is the area of this top face, and there is another face at the bottom which is the exact same thing. So this times 2. So that takes care of that part. Now let's find the area of the left hand face and the right hand face. Area of left hand face and the right hand face. And the left hand face and right hand face we're talking about, they have the dimensions of 2 by 10. So the area of this face is 2 by 10, which is 20. So it's 2 by 10, and again there are 2 of them. There is a left one and there is a right one. So that takes care of that part. Now let's move on to the area of, so we have done the top and the bottom, we have done the left and the right, now we have to do the front and the rear. The area of the front and rear faces. Area of the front and the rear faces, and the area of the front face is going to be this side right here is same as this side here, which is 2, and from here to here is 7. So the area of this thing is 2 by 7. 2 by 7, and again times 2. Times 2 because there is one in the front and there is one in the back. That's it. All we have to do is just add them up. So let's do it, shall we? So this is 70 times 2 is 140. This is 2 times, this 20 times 2, which is 40. That's 180 so far. And this is 14 times 2, which is 28. So we have 140 plus 40 plus 28. That's 8. 4 plus 4 is 8, 10, 0, carry 1. That's it. 218 square units. Square units. Whatever the unit happens to be. Do they give you a unit here? They do not give you they do not give us the name of the unit. So if we are measuring this length in inches, then you would say that the surface area of this rectangular box is 208 square inches. If we are measuring this in centimeter, we would say it's 208 square centimeter, or square yards, or square meter, or whatever the units happens to be. But it has to be square units because it's the area. 208 square units. That's it. I'll give you a second to get the unobstructed view of the blackboard before I erase it. The next thing we have to do is find out the length of the diagonal, which is a little tricky. Let's do it here. The diagonal that they're talking about, how do they phrase it? Length of the diagonal AB, actually they show us what AB is right here, this AB right here. A is located here and B is located way on the other hand, and we're looking for the length of this diagonal. Before we can figure out the length of the diagonal is going to come from, okay, listen very carefully, the length of the diagonal that we're interested in is going to come from this triangle right here. This thing makes a 90-degree angle. Let's call this thing point C. Point C. But we cannot figure out the length of the diagonal AB. This is the triangle, what it looks like. This is from A to B, or rather, sorry, this is from A to C. This is right here, and this is your point B. A to C is the floor diagonal. A to C is the floor diagonal. And we have to find that first. We already know what B to C is. B to C is same as from here to here, which is 2. This is 2. We have to find the floor diagonal. So I'm going to draw the floor here. The floor looks like this, obviously. The floor is very simple. The floor is 10 by 7. 10 by 7 is the floor. Let's put it the same way it's supposed to be. Floor is 10 by 7. And this is the diagonal that we're looking for. 10 by 7 is the floor, and the diagonal that we're looking for is the floor diagonal. And that, again, is a straight application of Pythagorean theorem, because this, of course, is the right angle, because is the rectangle there, 10 by 7. So let's call this x here, and that's our floor diagonal. AC is the floor diagonal. Let's call it x. Let's call it x. So this x here, x squared, again, simple application of Pythagorean theorem is what we're looking at. This x squared is going to be 10 squared plus 7 squared, which is 149. So the x is square root of 149, and that goes up here. Square root of 149, which is the distance from A to C. From A to C. Now we can figure out this part right here. Let's call it D for diagonal. We can figure out this part very easily by using the Pythagorean theorem one more time. By applying the Pythagorean theorem one more time, because this angle C is a right angle triangle. This thing here, where this side comes down at the floor here, that's going to make a right angle. So we already know this side from A to C, we just found out is the square root of 149. We know B to C is 2. We just have to find the D by using the Pythagorean theorem one more time. So let's do it here. We no longer need the picture of the floor, so I'm going to erase it. And now we're going to solve for the diagonal, and we're calling it D for diagonal. Diagonal squared, which is the hypotenuse of the triangle ABC. In the right angle triangle ABC, D, the diagonal that we're interested in, is the hypotenuse, which is going to be equal to square of that thing is going to be equal to square of 2 plus the square of 149. And that's just 4 plus 149, which is 153 D squared. Now the last thing that we're going to do is something that we have done many times. I've reminded you many times. These are simple things that you have to know. Is this number divisible by 3? The answer is yes, this number is divisible by 3. How do we know if a number is divisible by 3 or not? I'm not going to write here, but perhaps I should write here. We're done with the surface area. I'm going to erase the answer. A number is divisible by 3 if the sum of its digits is divisible by 3. If the sum of the digits of a number is divisible by 3, then the number itself is divisible by 3. Here what we have is 153. 1 plus 5 is 6, 6 plus 3 is 9. That tells us that 153 is divisible by 3. Let's do it here. We no longer need this part here. Let's do it here. 153. If we divide that by 3, how many 3's in a 1? 1 has no 3. That 1 goes and joins the 5, becomes 15. How many 3's in a 15? 15 has 5 3's. And how many 3's in a 3? 3 has 1 3's. What we find, in other words, 153 divided by 3 is 51, which should be no surprise to us, obviously, because 150 divided by 3 would be 50, and therefore 153 divided by 3 would be 51. Again, since we see 51 here, 5 plus 1 is 6, which means 51 is also divisible by 3. Let's divide 51 by 3. How many 3's in a 5? How many 3's in a 5? 5 has only 1 3's. 5 has only 1 3. The remaining 2 goes and joins the 1, and it becomes 21. How many 3's in a 21? 21 has 7 3's. So what we find is that we were able to divide 153 by 3, and we were able to divide the result by 3 one more time. In other words, 153 turns out that 153 is same as 9 times 17. 9 times 17. Therefore, D is square root of 9 times 17. 9 happens to be a perfect square, which was the whole point. It comes out with 3 times square root of 17. 3 times the square root of 17 is the length of the diagonal AB. Is the length of this diagonal AB that we were looking for in the picture. And that's it. But we have to know the process, we have to know the procedure, we have to know the concept, we have to have all of those things at our fingertips, because obviously we can't spend that kind of time, this amount of time in the real exam. We have to know one thing after the other as to how to do it. It's not very complicated. The problem itself is not very complicated, because all we did here was to apply Pythagorean theorem twice. That's it. It's the 2 application of Pythagorean theorem. Simple application of Pythagorean theorem is all that is required here. You have to apply it twice. But first you have to realize that in order to find this AB, we have to form this triangle here, ABC, which is a right angle triangle, in which case side AC is an unknown quantity, which happens to be the diagonal of the floor. And of course we know this is 10 and this is 7, so we can find out, that's the first step. Find the diagonal of the slope first, diagonal of the floor first, and once we have the diagonal of the floor, then we use that as one of the sides of the new right angle triangle. I'll see you tomorrow, okay? Tomorrow we'll do another problem very similar to this one. Very similar but a little bit different. A little bit more challenging, okay? I'll see you tomorrow. Bye now.